Hi, my name is Alex Zosel. I'm from Germany, Karlsruhe in the southern part. And thank you, Chessman, for the introduction, but we don't have a flying car, we have a flying taxi, because a flying car is perhaps with wheels, and we say a flying car don't drive, it flies. So you can start the video. So, our company comes from Karlsruhe. It's a small city in Germany. And we have a big city history because the revolutions of mobility are all out of Karlsruhe, because Mr. Drais invented the bicycle, the first bicycle in the world. In Karlsruhe also, Mr. Benz invented the automobile, and Heinrich Hertz, he got the knowledge of the radio signal, so the mobility of data is also out of Karlsruhe. So, and the next invention was 2011. We invented the first super drone. So we had our first manned flight in 2011 as a test for validating this technique. So this was not the aim to bring this to a product. The aim was, after we reached that aim, to make a product out of it, and also to have a vision for a future mobility system. So here you see how we produce the first prototype. It's full out of carbon fiber. It's like a production of a Formula 1 car. So everything is handmade and carbon fiber. It's really high class. Also, we have developed all the components by ourselves. So there's everything custom made in that aircraft. That was also needed because with the existing system, they are not efficient enough. So we have to do the motors more efficient than on the market. We have to do the rotors a little bit more efficient. And this is also a very interesting thing where we have aerodynamic simulations for that to bring at the end an aircraft like this out from the bottom up to fly. This was 2013. That was the first flights in an indoor. This is a 10-meter big rotor array, so it's a two-seater. It's not a small toy. Sometimes it looks on videos like a small toy. And here you see we make the whole testing thing that you have to do also for a normal aircraft. For the structure, it's an easy work to get a certification for an aircraft with structure because the rules are really clear. But the complicated thing was how to get this new kind of flying into a certification. So we have lots of sensors. We have an armada of sensors. We have more than 130 microcontrollers on board. And to combine this, and every controller has its own software, and how to show that is safe. Can you stop the video here, please? So the first step for certification was the structure stuff. That was like it's used in and common in the aviation in aviation. So, but how to show the authorities that this is safe? So we worked together with the authorities how to do that, and we made a plan. What can happen? What can go bad? So it's not only to stop a motor or to stop a battery. It's also have a lot of sensors. A sensor can not only go crash, so it can also send wrong data. For example, a high sensor can say, I'm not in 20 meters, I'm in 500 meters. So how the system compensates it. And we have the luck to fly with that aircraft with nobody in. And we switched off every component in flight, or more components. We send wrong sensor data to the system, and we had a whole failure matrix worked out with the authorities. And we can show them in a lot of flights that this aircraft flies already when we do all these failures in flight. So after this process, you can start the video again, we are happy to get a certification for the aircraft to fly manned in Germany. And that was really difficult. So the technical side is really difficult. So I think we are really up front in the world with the technique. So you will see no aircraft with that performance and this technique flying in the world. And on the other side, we are the only one have really a permit to fly in a country. So you will see here the permit to fly. It's from last year. And we can fly really around whole Germany where we want in the rules of the sports aviation. After getting the permit to fly, it's a two-seater. We don't want it to take the risk to put 2 people in for a first flight to show that it can carry 2 people, so we take me because I'm 2 pilots and 1 from the weight. So you will see that was the only reason that I'm sitting in. And that was really amazing because we could fly 4 years or 3 years. We could fly with that, but we don't have the permit to fly, the flight manned. So it's really hard not to fly. Here you will see I take off my hand off the joystick and it flies by itself. Normally the aircraft flies by itself. I have only a joystick to control it, and I can give you 2 sentences and you can fly it. So this is a really nice thing that it's so easy to fly. And this is the way how everybody can fly a helicopter in the future as a sports aviation. And after this, we make more tests. We go over the edge of some points. We say, okay, we tested high speed, we tested strong climb rates, we tested strong descent rates, we tested also flying in really hard conditions with really strong turbulence. And so I had more than 400 flights already on this aircraft for testing. These are now some ideas we have for the future, so we can build up a 1-seater for fun. We can produce a 4-seater, and also the field of work drones, like precision agriculture shown here. That would be no problem with that technique. But our aim is from the first day to have a mobility system, and this is shown by the Swiss Climate Summit in 2014. This was a vision of them. That was not our vision, but we are happy that the president that on the summit in front of before my speech. And this is how you can imagine how it can be in the future. But what happened since the last year? We produced a serial model, so we made out of this prototype a really high-class aircraft with nice leather seats inside. It's really a little more, it's more luxury as a usual sports aviation aircraft. And we started already to produce more of them. And the next step is what we will do in the future. And this is also not only having a helicopter for everybody to fly himself. The aim is to have an autonomous air taxi in the future. And now we need the sound. We are happy that announcement was made 2 weeks ago.
Dubai aims to become an example of excellence for future cities and to be transformed into the world's smartest city. The Roads and Transport Authority in Dubai, RTA, adoption of autonomous vehicles technology reflects the Dubai Smart Autonomous Mobility Strategy, which aims to transform 25% of the city's mass transit system to autonomous driving to enhance people's well-being and happiness and strengthen Dubai's reputation as a hub of innovation, technology, and the future. To achieve that, RTA has announced the signing of an agreement with the German Volocopter company, a specialist manufacturer of autonomous air vehicles, to launch the world's first autonomous air taxi, AAT, capable of transporting up to 2 passengers. The AAT is characterized by its autonomous flight. This enables the movement of people from place to place without human intervention or the need for a flight license. powered by electricity, the AAT's design of 18 rotors ensures safe cruising and landing of the taxi in the event of any rotor failure. The AAT's trial run will begin in the final quarter of this year. The trial operation and certification program will continue for 5 years. RTA will work with the Dubai Civil Aviation Authority to develop the world's first AAT legislative and operational guidelines. RTA is steadily marching towards the future by implementing the latest autonomous driving technology to establish Dubai's position as the city of the future. Roads and Transport Authority. We keep Dubai moving.
So we do also keep Dubai moving in the future with the Volocopter. And now we are really some steps nearer to the vision to have autonomous air taxis in cities, because the technique is just existing. We have these aircrafts and they are good flying. The autonomous systems are really good, but what is the aim of the collaboration with the Dubai guys? The aim is to develop really a safe system of hundreds of volocopters or air taxis, also for other applications possible, to make it safe in a city. And that's not only the aircraft itself, it's also about the connected system. And they are really in the front of the world with connecting systems. They have the control system in Dubai where they control every taxi. They have 52,000 taxis, and every tram, they know everywhere where they are and how fast they are. This is really amazing if you see what they have already, a security system for connected mobility in Dubai. And so for us, it's really important to be a technical partner for them, also for the authorities, to create this new kind of regulation. And this is a trail up to 5 years. So in these 5 years, we will also integrate other autonomous systems to trail and test it, that it's safe for a regulation. And after the regulation is ready, our aircraft is ready for market, because we have tested it with the regulators. So this is for us really a fast step. We thought we'd do it in 2 years. And we were happy 4 months ago when Dubai come to us and say, we want to do this program with you, because you are the most advanced system in the world with this technique. Okay, so I'm open for questions. And we have another 15 minutes, because my counter is already at 15 minutes, so.
Take here in the front.
Hi. Will it not be very, very loud to have all these helicopters buzzing around all the time?
Yeah, so this loudness, or this is the most important key for this technology. We are really, really low noisy, because we have a big rotor array. Perhaps there are some other projects in the world, they have much smaller rotors and less rotors. So you have to drive them faster and stronger, so it's more loud. So it's not only a decision of safety to have 18 rotors, also a decision how to get this aircraft really low noisy. And if you fly in 100 meters or 150 meters, you just don't hear it. So you have on the ground, you will in the future have already cars. So you don't have really loud noise. And also in takeoff and landing, this is also really key, that it's in takeoff and landing not so loud. So of course we want to land in the city and really a lot of spaces.
Okay, thanks.
Hey.
Hey.
So, yeah, you're undergoing testing right now with Dubai. By what year does the company hope for mass adoption throughout the rest of the world?
Sorry, your question.
So by what year do you,
Yeah.
as a company, perceive mass adoption of the Volocopter? That sounds like a...
Yeah, now
across the world.
Yeah, I think it's a process that is going really fast. So we think we have really early demonstration with 2 hubs where a lot of flying in one line, like it's for a bottleneck to solve a problem or as a showcase. And if you solve a problem in one of the mega cities with one of these systems, we have a lot of other cities they want it also for their bottlenecks. And so we will start with bottlenecks, solving problems, and then we have more bottlenecks in city, and then we will connect them. And then when the autonomous thing is really on high level, also you can jump from the routes to on-demand spots. And I think this is going really fast. I believe that 2030, it's 12 years, we have it in really 15, 20 mega cities, and we will have there 30,000, 50,000 aircraft there or more, for sure.
It's amazing. I look forward to my flight.
Ooh. All right. We got lots of questions going on. All right. We're going to take you here.
Hi.
Hi.
So when you start in Dubai, you said it's going to be like ready in 5 years for persons to fly, right?
No, this is a trail program. So at end of these 5 years,
Yeah.
they want it as a mass solution there.
Okay.
So it's a path to get there, a mass solution, because their aim is in 2030 to have 25% of their mass transportation autonomous, and they think that they need the Volocopter to do this, or perhaps other aircraft who can do this also, but this is the aim to have it in 5 years as really lots of them in Dubai. So.
Okay, and is it more expensive than a regular taxi with a car? Or how do you make it attractive for just the average person to use it?
So when we are in a large-scale production, it will be just the same cost like cars. Okay. So it's affordable. So I believe that everybody can use this, and I think the value is in the future is time. So you pay for time. So if you use a car and you need an hour, and you use a Volocopter and use 15 minutes, you pay perhaps a little bit more, but you have more time. So, and I think the coins in the future are time coins.
So, but now it's not only exclusive for like the rich elite in Dubai?
No,
Okay.
This is not the aim.
Okay, thanks.
Hiya. So what is the maximum density of your aircraft in the air? And do you see potentially you can take all the traffic on the ground into the air in a city with a large population density?
I think it's not that we can make all the traffic, all the movements on. So it will be a complex system of a lot of different kinds of movements. We will have the Hyperloop. We will have, I hope, more bicycle kinds of electric devices are very light, and a lot of things. I think in the future you will have a device like a smartphone. I think we don't have smartphones in 20 years or 15 years. I don't know what we have, but we don't have smartphones. And you want on demand. I want from here to there, and the system gives you the kinds you can go. You can say, okay, I need to be fast, not so fast, cheaper, more expensive, fast, and the system gives you the way you go. And we are one part of the system, and our aircraft, it cannot be so fast. So we have accepted that we can go fast like a winged aircraft, but we can really fly really stable in inner cities and very low noisy, and takeoff and landing really extremely stable. And this is, so we have the space of the urban cities, and there we are strong, and we have there also the on the ground also cars. We will lose the cars on the ground. I don't believe that.
All right. Thank you very much, Alex.
Okay.